Good morning and welcome back to Dr. Logic awkwardly does logic in her living room. Today we are going to look at the first set of the proof rules for propositional logic, and these are the bookkeeping rules. If you've watched the proof theory videos for the syllogistic, you'll find that these rules at least look very, very familiar. So there's two rules. One of them is the assumption rule and one of them is the reiteration rule. So let me bring up my whiteboard so I can give you a precise definition of both of these. There we are. So first one, there we go. We've got our bookkeeping rules, assumption, and reiteration. Assumption just is, if phi is a well-formed formula, you can write it down in your proof and label it an assumption. So any line of the proof, however, we will ensure that every assumption gets one of the vertical scope lines and a horizontal line underneath just to say this, to kind of indicate visually, this is an assumption. So it looks something like this. If phi is a well-formed formula, then phi can be written on line n of a proof with a new horizontal and vertical scope line. So for instance, suppose that we have a proof with various things going on, then here at line n, I can introduce a formula phi, annotate it with assumption, and that's it. A couple of things for how this assumption rule differs from, say, the premise rule of the syllogistic that we introduced. Every assumption will have its own scope line, except at the very beginning of the proof, where you might be given a group of assumptions or a group of premises, and those, you can write all of those down in one go. They are kind of being assumed simultaneously. They each get written on their own line, but you only get one scope line for it. Every new assumption after that generates a new scope line. At the end, we will have to make sure that we have discharged all of our assumptions. So we've gone back so that we only have the scope line of our initial premise set or no scope line at all. So a proof where all of the assumptions have been discharged and you have no scope lines left anymore is a proof of a theorem, something that doesn't have any assumptions or any premises. So this will become more clear as we see examples, and you can see when you are able to discharge an assumption, certain rules will allow you to do this and certain rules, of course, won't. But the other thing where the assumption rule here differs from the one in the syllogistic is that we are free to make as many assumptions at any time as you want. So at line M here, I could assume psi, and then within that, I could assume, say at line I, some formula gamma, and so on and so on and so on and so forth. You can always assume anything you want. However, in general, once you start actually doing proofs, you won't want to assume things that you don't know how to discharge. So when we talk about proof techniques, we will talk about identifying when is it appropriate to make an assumption, even if it's always legal to. You might not necessarily want to. So there we have the assumption rule. Now, the reiteration rule is basically exactly what you would expect given what we've seen for the reiteration rule in the syllogistic. If you have a formula written on a particular line in your proof, then you can write it down again on another line lower down. There are a couple of caveats though, because we have these this kind of more freedom and flexibility with our assumptions. We need to kind of keep track of what formulas we've derived to depend on what assumptions. So with reiteration, you can always bring something in so that it depends on more assumptions than it used to. You can do this by checking the scope lines. You cannot do it so that it depends on less. So you can always reiterate into a subproof, but you cannot reiterate out of a subproof. You have to use one of the other rules to do that. But let's go ahead and write our reiteration rule down. Reiteration says that if you have a well-formed formula phi on line I of your proof, where I is some line in the proof earlier than n, then you can write phi on line n, provided that line n depends on all of the same assumptions plus possibly more. So I'll add that caveat in there, plus possibly more, as line I. So you can always bring it within a subproof and introduce more assumptions, but you can't pull it out and remove assumptions. So the formal way of writing this down is just, if we have on some line I a formula phi, then later on at some line n, we can write it down, and the annotation is reiteration of line I. So there are your bookkeeping rules. Every single proof will start off with an assumption. There's no way around this. You will always use the assumption rule first. Reiteration works basically exactly as it does in the syllogistic proofs, with the added caveat that you need to pay attention to what your assumptions are, because in this context, you are allowed to make as many assumptions as you want. However, just because you're allowed to doesn't necessarily mean that you want to. So when we talk about proof techniques, I will give you advice on when you actually want to make assumptions and when you don't. But there you have it, the bookkeeping rules for propositional natural deduction. Next time, I will give you the rules for the conjunction. Each one of the logical operators is going to have a pair of rules. One that tells you when you can introduce a formula with that as the main connective, and one that says when you can eliminate a formula that has that as its main connective. So 2 rules for each connective. Next video, I'll give you the ones for conjunction. See you then. Cheers.